Let's look at Hess's law. It's an important law in thermochemistry. And it states that the change in enthalpy for a stepwise process is the sum of the enthalpy changes for each of the steps. Hess's law states that the change in enthalpy for a stepwise process is the sum of the enthalpy changes for each of the steps. It's really just looking at the definition of what a state function is. All that matters is where you start and where you wind up. It doesn't matter how many steps it takes to get there, just so that you wind up at those positions. It was formulated by Germain Hermann Hess, who lived from 1802 to 1850. He's born in Switzerland, but lived most of his life in Russia, and he's known as the father of thermochemistry. So when we're applying Hess's law, we're going to follow these rules. What we're going to do is we're going to manipulate thermochemical equations in a manner that gives the overall desired equation. And so we need to remember how we go about manipulating these. We always have to specify the physical states of the reactants and products, because they help determine the actual enthalpy changes. Whether water is a gas or a liquid becomes very, very important. You just have to specify so that you know what you're working with. We multiply an equation by a factor. You multiply the change in enthalpy value by the same factor, the delta H. So if you have to multiply a reaction by 2, you'll multiply the change of enthalpy by 2. Whenever you reverse an equation, you change the sign, but not the magnitude of delta H. The size of it stays the same, you just change the sign from either positive to negative or negative to positive. Then you add the delta H's, the changes of enthalpies for each step, after you've done the proper manipulation for all these steps. And what we'll wind up doing is just algebraically canceling out various entities so that we wind up with the desired equation at the end. This process is very useful for calculating enthalpies that cannot be found directly. The table of heats of formations that you've seen, they've oftentimes been determined experimentally, and from the ones that we determine experimentally, we can then calculate what it might be for other compounds that we might not be able to actually carry out in the lab. And this is an important process to learn, because as you go through chemistry, and in Chem 112, you'll be talking about things like free energies and other quantities where we're going to use similar types of processes in determining the overall changes in reactions.